Okay, we've got a situation with a cyclist waiting at traffic lights. Unusual for a cyclist to wait at traffic lights, but this happens sometimes. When the light turns green, the cyclist accelerates uniformly from rest to a speed of 5 meters per second in 45 seconds. Maintains that speed for 2 minutes, then a rabbit jumps out, and the cyclist stops in 1 second. Sketch a velocity time graph and find the total distance travelled. So, a velocity time graph has got two axes. One is velocity and one is time. Time is always the horizontal. Got the velocity vertical. So it's waiting at traffic lights, so at the start it's got no velocity, and then it accelerates uniformly from rest to a speed of 5 meters per second in 45 seconds. So it's a uniform acceleration, so that is a straight line. If it was not uniform acceleration, it would be outside the bounds of the M1 exam. So at this point here, t is 45 seconds and v is 5. Now the cyclist maintains this speed for another 2 minutes. 2 minutes is 120 seconds. So it's a constant speed to this point here. So it's still 5 meters per second, but the total distance, the total time travelled now is 165 seconds. Then the rabbit appears and the cyclist screeches to a halt and stops, so there's no velocity, and it stops just in front of the rabbit. Now in a velocity time graph, the acceleration is equal to the gradient, and the total distance travelled is equal to the area under the graph. So in this case we're not asked about acceleration, we're just asked about distance. So the distance is the total area under the graph. So we've got a triangle, got a rectangle, and we've got a triangle. So this triangle has got base 45 and height 5. So the area is a half times 5 times 45. This rectangle has got base 120 and height 5. So that's 120 times 5. Then the tiny little triangle at the end has got base 1 and height 5. So the total distance travelled is all those numbers added together, which is 715 meters.